G'day everyone, welcome to another video. Today we're going to look at a technique called integration by parts, and there's a lot of a lot of information on the screen. But basically, integration by parts is, I guess, like if you remember the product rule back from when we did differentiation, integration by parts is sort of like a bit of a reversal of the product rule. And if you have a look at that formula that I've got written there, um, that you can sort of see how potentially this has been rearranged, because the derivative of uv is equal to u times v dash plus v times u dash. And so if you rearrange that around, you change the order of things, then you can actually, if you write the integral of one and then rearrange, etc., then you get the following. So the integral of u times the derivative of v is equal to u times v, take away the integral of v u dash. And you might ask, well, what's the purpose of that? Like, are you really getting something that you can integrate? And actually turns out to be very useful. So what happens is that you might have the product of two functions in an integral that you can't integrate any other way. A u substitution doesn't work. It's not an inverse sign. It's not any sort of trig. It's nothing that's known to you. But if you can apply and find a function for u and a function for v dash, and somehow that it works out that you can change it into this, and as long as you can change it into something else that is into, you can find the integral of that. If you can find the integral of that thing, then you can solve it. And so that's what we're doing here. We're trying to sort of rearrange it to try to change the shape of it, trying to change the form of it so that we can integrate it. So just a couple of little things before we get started. The hardest probably thing about the integration by parts is actually how to choose u and how to choose v. It's not always obvious which one is which. Okay, and so I've just got this sort of saying here, and the saying is u, don't be late, be early. All right, and so when you're choosing your u, you look through this list of late, and you notice it's not spelled in the normal spelling of late. And the earlier on in this list it is, the better it will be if you choose it for u. Okay, so in other words, logarithms are really good choices for u's. The reason for that is because the derivative, and remember in this yellow here, you're going to end up with the derivative of u. And so if the derivative simplifies to something nice, that's a really good choice for u. So logarithms are great because logs simplify to 1 over something, 1 over x, or whatever. So they simplify really nicely with the derivative. Inverse trigs, they simplify not super nicely, but 1 over square root of 1 minus x squared, something like that. Not too bad. They sort of come out. Algebra stuff is sometimes good and sometimes not. You'll see as we go down the list, they're getting worse. Because algebra, like if you think about x squared, the derivative of that will be x, so that might be helpful. But the derivative of x, if you choose u being x, then u dash will be 1, and so that simplifies really nicely. And so if it's just a linear sort of term like x or x plus 3, that's perfect because the derivative of that simplifies it really simply. So algebra can be good, but it can also be not so good. Good choice for you. Or a trig. So we're getting further down this. Trigs are not very good. And if you think about trig, when you find the derivative of trig, like say sine, you get cos. And so it doesn't actually simplify the integral at all. It doesn't get easier. It just sort of stays the same. And the same with exponential. They don't change. If you've got e to the 3x plus 2, the derivative of that is just e to the 3x plus 2, times by 3. So it doesn't actually simplify anything. So the rule is, when you're choosing your u, don't be late. So you want it to be as early as possible in that list. That will make your life easier. I'm not going to look at that thing I've written in blue just yet. I'm going to go straight to an example to sort of talk about what I just did. So let's have a look at this. You've got an example. I've got an integral here, x times cos 2x. So having a look at this, you think to yourself, well, I can't do a u substitution. That doesn't work. There's sort of nothing else I can do here. There's no sort of product rule or anything like this. So you probably come to the point where you go, well, maybe I'll give integration by parts a try. And so what we have a look at is, like, can we define a u and a v that will make this thing work? All right. So the recommendation is that u is don't be late, be early. So Is there a logarithm? No. Is there an inverse trig? No. Is there algebraic? Yeah. Okay, so there's an algebraic function there, there, and there's a trig function there. So what I'm going to try is I'm going to say let u be x, and I'm going to say v dash is going to be cos 2x. Okay, so they're my sort of choices that I've made, and the reason I'm thinking I don't know if it's going to work. That's integration by parts is always like a bit iffy. Like we'll just see what happens, because what's going to happen is it's going to end up being the integral of v. So the integral of that times by the derivative of that, and the derivative of that is 1, so that's going to be nice. So I think it's going to be successful, this particular method. So let's have a look at that. So u is x, v dash is cos x, and the reason I've chosen that is because x times cos 2x is what the integral that we've got here, and that's the formula that we've got up there. That's why I chose it. U is x, v dash is cos 2x, and then we're going to go and do some working out here. So if u is equal to x, then u dashed is equal to 1. If v dashed is equal to cos 2x, then the antiderivative of cos 2x is going to be sine 2x, but it's going to be half sine 2x. So I didn't write down v. So v is equal to that. The antiderivative of cos is going to be sine. Good. And so that's sort of our sort of chunky sort of working out. And now we're going to apply integration by parts. I'm just going to leave it right there. I'll go to blue. And that's going to be equal to, right, so that's the integral of u v dashed. Now it's going to be equal to, I'll just write it, u v take away integral v u dash dx. And so that's what it's going to be equal to. So let's now put some things in to here. So u is x, v is half sine 2x, okay, and then take away integral of v. What was v again? Half sine 2x times by u dash, and u dashed was 1. Okay, so I've just applied integration by parts, and now let's just stare at it for a second. So has it gotten easier? Has it gotten something that we can actually find the integral of? So that, yep, no, I mean that's that's part of the answer. But this here, can we integrate that? And that's just a sine function, so we can definitely integrate that. So now we're in a place where we can actually find the answer for this, which is fantastic, which is great. And you can see that's sort of how integration by parts works. So we'll just put this x on 2 sine 2x. We'll set that sort of out the front, and then minus, and then we're going to integrate that. So it's just half sine 2. So integrate that. I'll just leave the half there. Sine goes to negative cos 2x, and there's a factor of half, so I'll just delete that as well. It's going to be, oops, I didn't press the delete button. Just delete that negative, and I'm going to put negative half. Okay, so negative half in there for the integral of half sine 2x. Sorry, so the half came out the front. Just double checking my work. Sine goes to negative cos, and we divide by 2. It's an integral, and because we've just done an integral, I'm going to plus c right there. And so then we're pretty much done, and we just need to simplify it. So it's just going to be x over 2 sine 2x, and then that's going to be plus 1 quarter cos 2x plus c, and that is my answer. So I hope that makes sense. Just to summarize, what we need to do is choose a u and a v dash such that the u will simplify to something, and hopefully what you're ending up with is that v u dash area, that's going to be something that you can integrate. So that's why you're trying to choose those. And so the guide is to choose something that's early in liate. Don't be liate, be early. Okay, so choosing something early there. Okay, I'm just going to do one more example for today because I just want to show you this. So an integral of arc sine. Let's have a look at this. We haven't talked about the integral of this. We know the derivative of it, but we don't know the antiderivative of it. So let's have a think. Here, we've got no way to move forward. We have no idea what this is equal to, but there's just one suggestion, and I've just sort of put it up here, if you have an integral function of s integral that can't be done, try doing integration of parts with u is equal to f of x and v. I should have said v dashed. My apologies. I've made a mistake there. V dash is equal to 1. In other words, yeah, your function v dash is just 1. And so you multiply whatever the function is by 1. That's what you've got. And maybe that might get you out of jail and you might be able to simplify this. So let's have a look. If we've got arc sine x, what we can essentially say is that this is equal to, and I'll just write it here so you can sort of see, that's essentially the integral of arc sine x times 1 dx. So you can sort of see why I might have done that. And so what I'm saying is that u, what did we say up here? We said if you've got that, u is f of x. And so let's say u is arc sine. Okay, let's say u is equal to that. And we're saying here that v dash is equal to 1. All right, and let's see if this works for an integration by parts. Okay, so if v dash is equal to 1, then v is equal to the antiderivative of 1, which is x. And what's the derivative of u? U dash is equal to 1 over root 1 minus x squared. Okay, so there's my bits and pieces. Let's see. Whoops, I've just totally gone through everything there. Okay, so there are my bits and pieces. And now let's do this, right? So equals. Remember your formula. So that's my uv dash there. And so integration by parts, it's equal to uv. I'll just write it down. So uv minus integral u dash v dx. Always double check that because vu dash, always double check that because I make mistakes, do the wrong derivative or the wrong thing. So equals uv. So its arc sine is u, v is 1, so I'll just leave it like that. So I'll just put a 1 so you can see what I'm talking about. 1 times arc sine x minus the integral of u dash, and u dash is 1 over 1 minus x squared. That's my u dash, and my v is x, and so times x dx. Okay, so I've just used that. And so the question is always, once you've done the integration by parts, can you now integrate that? So that's the question. Can you integrate that? And looking at that, I go, oh yeah, that's a u substitution. I can actually sort that guy out. Okay, so I'll just change to a different color. I go, all right. So therefore, let's have a look at the integral of x over 1 minus x squared. I want to see, can I find the antiderivative of this? I can see that that is a u substitution. So if I let u equal 1 minus x squared, then du dx equals negative 2x, which means that dx is equal to 1 over negative 2x du. Okay, so just some working out there. You might do it a slightly different way. That's how I do it. And so that is equal to the integral of x over square root of u, and dx is 1 over negative 2x du. Now I'll go across, so I'm not taking up too much space. So those x's cancel out. X cancels out with that x. And so we come down to, so we're going to have negative half out the front. So it's going to be negative half integral u to the negative half du. Have I missed any negatives? Negative there, no. All good. Yep, so that's what it's equal to. So negative half, we've got u, negative half plus 1 is positive half, and then we need to divide by positive half, and so that essentially cancels out that, because half divided by half is 1, that cancels out, and so that's equal to negative square root u. Okay, and just to finish it off, that's negative square root, what was my u again? 1 minus x squared. So that integral there is just equal to negative 1 minus x squared. So now we can finish this off. So therefore, the integral of arc sine x dx is equal to, where did I have it written down? All right, back up to here was arc sine x So I'm just what I'm doing is I'm just back up here now, and I'm just sort of copying this down. So arc sine x, take away the integral of 1 over 1 minus x squared, which is, we just wrote negative 1 minus x squared plus c, because we just integrated. And so we'll just, that's double negative. So arc sine x plus 1 minus x squared plus c. So that's my integral for arc sine x. So that's a way that we can use integration by parts to find the integrals of things that we don't really know much about. So we go, well, I can't do it. So what I might do, I might just try setting u is equal to f of x and v dash equals 1, and to see if that might get me out of jail for this particular integral. Hope that makes sense. I'll see you in the next video.